just go ahead and read it. Maybe read it twice. Pretty standard application problem that you would see in a book. All right, so we've got the sales of lawnmowers. Liam, you can tell I would pick that one. But if you think about it, lawnmower sales probably go up and down. There's probably a time where people aren't interested in buying a lawnmower, and there's probably a time when they're very interested. When things go up and down, they tend to follow some type of sinusoidal pattern. In this case, a cosine equation, which we know is essentially the same as a sine equation, just shifted. Now listen, when you look at this problem, it's not too terribly hard, but it's meant to give us a little bit of a perspective. One of those things is to see that t is in months, and there's a little bit of a connection there with t equals 1 being January, kind of good basic stuff. But you see that pi over 6? I want that to be what maybe catches your attention, that pi over 6 right there. This is one of those things as you guys keep maturing in trigonometry, when you see a number like that, basically, I want to be careful how I say that. That's not a radian, but what that is doing is that is changing our t value to be in radians. So basically, when you see pi over 6, when you see a value that has pi in it, you not assume, but you know that this equation's in radians. So when we go to do something on our calculator, we'll have to switch to radian mode. That's something to keep in mind. Okay, now if we're going to solve this using algebra, pretty straightforward math here. You can plug in what you're given, and you can solve for what is unknown. You're given $100,000 in sales, so you want to plug that in for S. Now be careful, we don't actually plug in 5 zeros. If you read the problem carefully, it's already in thousands. So we plug in 100, but what we're really doing is plugging in 100,000. All right, and then we've got ourselves an equation that we can solve for t. Now, again, not a real hard equation. Actually, I knew I was forgetting something. I was going to hand back your mini check. You guys solved some equations on there, but let's go ahead and finish this. Obviously, you're going to subtract 74 from both sides. You get 25 and a half. Then you're going to divide both sides by negative 43. Honestly, things that you could do on a calculator if you wanted to. I'm just showing it so you can see. And we get this number, negative 0.58. Now, before we go any further, kind of two things here. One thing may have been a little bit of an oversight, or maybe you were wondering, what about that? Because it said exceed 100,000. It did say exceed, and then I put an equal sign in here. Now, if I want to exceed 100,000, maybe I can just make this a greater than sign. And it seems like it would make sense, and actually it's not wrong. I'm kind of going back through and making it say that it's going to exceed 100. When I get down here, I'm going to get a little bit nerdy with you, a little bit of a trig nerd, okay? Because first of all, the next step is to do an inverse. Anytime you do an inverse, you always get an angle. It's going to be in radians, but whenever you do an inverse, you always get an angle. Secondly, though, it's saying that cosine is equal to a negative. This is kind of the nerdy part. When a cosine is equal to a negative, that means that there's a triangle that has a negative x value. Okay, now it actually would mean then that this triangle should also satisfy this problem, because again, when cosine equals a negative, and this is kind of the nerdy part, that means that there's one of those two triangles, or maybe actually both of those. Okay, now let's do the inverse of this number. In radians, if you have it on your calculator, you can do the inverse of negative 58. Just kind of want you to see the number. I'll show it to you, but do you understand what 2.19 represents? Do you understand what 2.19 represents? It's an angle. Now, it's in radians. It's in radians, but I want you to realize that it refers to this rotation, this angle. Okay, and by the way, remember that the x-axis, if it was in radians, would be 314. So we get this 219 number. I took the inverse of negative 58.58. Make sure you're in radians. But that's good. That's why I want you to do it on your calculator. Don't just copy it off the board. Now, if you're saying, why are you drawing this little triangle? We didn't have to do that for like any of our, kind of basic equations that we did on the mini check. Well, because I want you to see that there's another angle. Now, there's another angle that, according to this problem, would satisfy this idea of equaling 100,000 sales. To find it, we're not going to do the inverse again. We're still going to get 2.19 if we do the inverse again. But we're going to have to use a little bit of this triangle trigonometry to help us decipher that pink reference angle and then get ourselves over to this other rotation. I just want you to understand this other rotation would be another place where this equation would be satisfied. And we're talking about sales that go up and down. It would be nice if we would know where we are at the beginning and then at the end of that up and down pattern. Try it with me. We want to get this pink angle. I know it's in radians and it makes it a little tricky, but basically the difference between 314 and 219 is that little pink space. I did it ahead of time and it came out to be about 0.95. 0.95 can then transfer down to this other reference. Okay, now again, 0.95 is just the difference between the x-axis and our terminal side. And now you can do a little bit of simple thinking about 3.14 and adding another 0.95. 3.14 adding another 0.95 would come out to be 409. Getting a little nerdy with you. These are angles. They are the result of an inverse. So when I went from this step to get 219, I could also make an argument that I could have gotten 409. Because 409 is an angle, and an angle always comes from an inverse. What we're suggesting here is that to go from this line down to this line was, again, an inverse. Now, this no doubt is some new thinking. If you're like, where'd you pull this out of? I'm just trying to challenge you a little bit so that you can see that we can use triangles to actually find both sides of this answer. We're going to use a graph in a few seconds, and you're going to make a connection. Let's finish this problem. You would definitely want to solve for t. So we kind of have to take these answers, these angles, and basically convert them. When you divide by pi over 6, you're converting them to be actual t values. And of course, that's what we're trying to find in this problem. A month, a t value. And I hope you're trying that on your calculator so it can spit out some numbers that are supposed to make some sense here. This would be the t value of 4 and a t value of 7 with the decimals. Four should be approximately April, January, February, March, April, and 7 should be July. Now we could get a little more specific about the actual day of July. Please do not say that it's July 81st, as months, remember, are out of either 29 or 28, 30, or 31 days. But just get you the idea that these numbers represent months. I got a little loosey-goosey on the greater than sign, didn't I? It was a greater than sign, and then we kind of made it an equal sign, and then we didn't talk about it. Let's look at the graph. The graph is supposed to shed a little more light. And like I said, actually make a connection. Now, you guys turned in 4 graphs. You kind of used the graphing method. I did that on purpose so that we could try to transfer that to an application problem. But I'm going to switch things up just a little bit. Instead of solving this for 0, now listen carefully to this. Instead of solving this equation for 0, I'm instead going to just graph both sides of the equation. And just like you've seen in an algebra class, we can find the intersection of those two sides. Okay, so this is just a slight variation from what you did on Friday. Instead of setting equal to 0, we're actually just going to graph both sides and look for an intersection. Whenever you do a word problem, you have to think about the window. I know, you have to think. I'm just kidding a little bit, but think about the x values. Those are months. Okay, it would make sense to go a full 12 months. I'm going to go -1 to 14 just because I want to go a little beyond. But the x values are months. The y values are sales. Okay, we have at least a roundabout sale, 100,000. Now you understand if 100,000 is our maximum for our window, then we're going to stop right where we want to see the action. So, maybe I could go to 200,000. Basically, I could go a little beyond. Listen, as you play with windows, you go back and you change the numbers. I kind of given you the answers I found after I played a little bit. Go ahead and graph it. You should be in radians. You should see a cosine wave that kind of goes up and down. That's the sales. And then we're looking for, now do you see what we're looking for? We're looking for this brown interval, right? If you think about it, that would be when the sales exceed everywhere above 100,000. Now, do you realize that brown interval starts and stops at our two sort of nerdy numbers? Okay, these nerdy numbers that we found are represented by these 2 brown dots. Now, there's an option in the calc menu. Same calc menu I showed you Friday. It's second trace intersect. This time we're going to choose option 5, intersect. And this works a little differently. It's not a left bound, right bound thing. It's actually a first curve, second curve thing. You put the little spider on the first curve near the answer, hit enter. Put it on the second curve near the answer. It should already be there. Hit enter. Make a guess. Hit enter. Enter, enter, enter. And the hamsters spin around inside the calculator, and out pops the exact answer. Okay, we get 4.19. 4.19. And then if you would like to try it over on the other side, second trace, intersect, enter, enter, enter. How's it going?
I just did the other side.
Oh, okay.
Yeah, I did the other side too.
You want to see that again?
Yeah, I'm just confused. Because, I keep going to the graph, and then I go back to the window, and then it changes back.
Okay. Don't hit zoom trig. because what that's doing exactly what you said, it's changing the window back. Just hit the graph button. Remember, when you use a calculator and you're officially turning in some work, show your work. So a little sketch, some numbers on it would be helpful. And we need to make a final answer. Okay, we've done some good math, but at some point we need to make a good answer here. So even though I was a little loose on the greater than signs over here and it kind of changed to equal signs, I'm ready to make a little statement where we could say sales exceed 100,000. And then here's the key part between April and July. Listen, if we want to get a little bit more specific, we could convert the decimal of April, simply multiply 0.19 times how many days are in April. I should remember this because my wife, her birthday is the last day of April, so there's 30 days. Okay, so that means that the lawnmower sales right around April 6th. And then what do we got for July? 0.81. That's like the fraction of the month. How many days in July? Something like with your knuckles or something. You ever see that? I think if you how many the knuckles represent 31, or maybe you just have it memorized. So 25, the 25th day. Okay, that's just some extra stuff. I'm not super concerned, but makes the answer look a little bit better. I'm not really sure if there's another method. I had letter C down there. If there's another method, I don't see anything that we need to talk about. We kind of did the other method when, again, we got a little nerdy here. Okay, trying to think about getting angles with triangles. There's 4 problems that I tried to kind of find something that was decent instead of just giving you random problems out of the book. These 4 problems on the back of the paper, again, are pretty decent. They will make you think in some new ways. They will use some strategies I showed you here. Okay, and you have some time to start working on them. Make sure you read the problem out of the book first. Then read my hints. Students get confused when they just read my hints and they're like, I don't know what I'm doing. You have to read the problem out of the book because it'll tell you the question and obviously what you're trying to find. Do this in a way that you can have some space to organize it. Okay, so I don't think you're going to squeeze it on the back of that paper. All right, and then just kind of think as you're working through it today, during school, maybe tonight, is this something that you want to finish for tomorrow and just kind of have it done? Or would you like that extra day, which turns into an extra week? But if that's the case, then you can turn it in the following Tuesday.